Good deal. So we're going to kick this off here. It's funny because I've got to still face this way since we have the camera, even though everybody felt it necessary to congregate by the exits, but that's okay. On behalf of the Board of Directors of the Bennington County Industrial Corporation, I want to thank you all for joining us here today for our second annual Composites Forum. As many of you are aware, this is a burgeoning industry both for our country and more importantly for Bennington, and it's wonderful to see the support that we're receiving in our community to move forward with this and make the composites cluster a priority in our future. Most importantly, I want to thank Dick Sears for the tremendous support he has shown over the years, both for our composites cluster here in Bennington and also the state's regional development corporations such as BCIC. Also, I'd like to thank the sponsors of this afternoon's event, Command Composites, Plasan North America, Plasan Carbon Composites, the Bennington Banner, the Manchester Journal, and GVH Studios. These organizations recognize the importance of our growing composites cluster and want to see the industry continue to grow in our community. As I've learned more about the composites industry over the past few years, I can't help but be reminded of the scene from The Graduate with Dustin Hoffman there. You know, it's one of those that I just want to say one word to you. Are you listening? One word: plastics. There's a great future in plastics, and I want you to think about it. It's a classic scene, and it was almost 50 years ago. Today, here in Bennington, I have one word for you: composites. There's a great future in composites, and I want you to think about it. We live in a world where the focus in industry has become lighter, stronger, faster, more fuel efficient, and most of all, safer. The materials we are working with here in Bennington are cutting edge and leading this change. Be it in the auto industry, aerospace, medical, or military, to name a few, the technology that is being developed and the products that are being produced here in Bennington are all working towards those goals: lighter, stronger, faster, and safer. If a client were to come into my office looking for a growth stock or a growth industry with strong prospects in the future, this would certainly be towards the top of the list and a part of any discussion. One of the great things about having the composites cluster here in Bennington is the jobs that this provides. Governor Shumlin recently released a report that indicated the average salary of a manufacturing job in Vermont is $52,000. These are skilled jobs with high pay, great benefits, and significant upward mobility. I personally see this every month through my work with the Bennington Young Professionals. Not only are we providing great jobs for people who already live here in Bennington, but we're attracting engineers from all over the country: Florida, Ohio, Iowa, to name a few. A report we released last week entitled Growth Opportunities in Global Composites Industry 2013 through 2018 went to great lengths to emphasize that the future of the composites market is going to be highly competitive, and the companies with innovative capabilities can be anticipated to thrive and gain market share. We're going to need more of these engineers in the future as we work to streamline processes, create new technologies to develop and create product, and most importantly, innovate to find new uses for our various materials. For Bennington to continue on its upward trajectory, it's critical we continue to attract and retain the skilled labor, engineers, and other creative minds necessary for Bennington to maintain its competitive edge in composites. Our focus on the development of the composites cluster is a tremendous step in the right direction. Now, as much as I'd like to believe you're all here to listen to me pontificate about the virtues of the composites industry, I know that's not the case. So, Ted's not here yet, so is Ted coming down the hallway? No? Okay. So then let me introduce to you James Salerno, who is going to be talking to you from Plasan Carbon Composites about what's driving composites in the auto industry.
All right.
Thanks, sir.
Okay, so to understand why we're putting composites on cars, why there's this huge draw to composite materials for the automotive industry, we have to understand why mass production matters. The primary driver for this, for the whole fleet, for your typical cars, is CAFE requirements. Now that's corporate average fuel economy. So per miles driven, per the whole thing, Ford, everything from a little tiny Ford Fiesta all the way up to an F-350, they all have to hit a certain average fuel economy for the whole fleet of vehicles. Now right now, that's 27.5 miles per gallon. Certain companies exceed that, and they can put that as a credit against the future development of their cars. But it's been that way since 1990. We've sort of been hovering right around just about a little under 30 miles per gallon for corporate average fuel economy. The Obama administration has mandated that we have to increase this. So we're talking about by 2016, we have to hit 34 miles per gallon. By 2025, just 12 years from now, we have to hit 54.5 miles per gallon. That's nearly double where we are now. How are we going to get there? You can get there by, improving internal combustion engine technology. You can get there by employing, hybrid powertrain designs. But there's one thing that's universal. If you make a car lighter, it will be more efficient. It's the equivalent of reducing gas prices by $1 per gallon, hitting these higher average fuel economy numbers. We're talking about reducing our oil consumption by 1.8 billion barrels of oil from now to 2016. It's taking 177 million cars off the road. And it's also about beating your neighbor. You got a Ford, I got a new Viper. You got a Corvette, I've got a Ferrari. I've got a special edition. Mine's lighter, mine's faster. I brought a bigger hammer to the party than you did. So it's exciting for me as a car guy to be involved in this, because the technology that we're developing in the auto industry is enabling a level of automobiles that was impossible 5-10 years ago. Let's talk about what this means for everybody, because not everybody's going to get a Dodge Viper. They're $115,000, $120,000. Let's talk about for a regular car. What does this mean, putting these lightweight components on cars? You go down to Honda, Toyota dealership, wherever it's going to be, other brands are available. You get a regular economy car. You're talking 140, 150 horsepower in a car that weighs probably 2,800, 3,000 pounds. And it gets about 32 miles per gallon. If you take 100 pounds out of that car, you're talking about a 2% improvement in fuel economy. Now that doesn't sound like a lot, but if you figure 32 miles per gallon, 2%, you're getting 33 miles per gallon. Over a 17-gallon tank of gas, that's another commute to and from work before you have to fill up maybe. So it adds up over time. And these incremental changes and improvements, taking 100 pounds out of the vehicle here and there, it starts to add up. Now this is going all the way to the other side, to the sport and exotic cars. You're improving the power to weight ratio of the car. You're getting more bang for your buck. You put an engine in a car that makes 500 horsepower. If the car weighs 2,000 pounds or 2,500 pounds, that's simple math right there. You know which car is going to be faster. For the new Viper, the SRT Viper, they managed to increase the engine output by 40 horsepower. But that's only part of the story. The more important part of the story is they reduced the mass of that vehicle by roughly 100 pounds compared to the old car. So what else does it enable? Reducing the mass of a vehicle. So if the car weighs a couple of 100 pounds less, look at all these components that go into a car. Thousands, tens of thousands of components. If the car weighs 500 pounds less, okay, maybe we put a smaller engine in there. The engine doesn't weigh as much. Maybe we could put smaller brakes, smaller suspension components. Everything starts getting lighter on the car. Just as a factor of employing composite materials and reducing the weight of the body, the weight of the crash structures, some of the hard components that have to be made out of metal. Since the car is lighter, it doesn't have to work as hard to accelerate, it doesn't have to work as hard to brake. You can start peeling weight off left and right. But that's not it. It also increases the vehicle safety. This is the SRT Viper right here. I was part of the design team that developed this car for Chrysler. 50% of the exterior of the car is carbon fiber. The roof of this car is carbon fiber. If this car rolls over, carbon fiber is saving that driver's life, not metal. Metal can do the job, but carbon fiber can do it better, and it's lighter to boot. But it's not just crash. This is the first time this model year that they've started incorporating driver aids into the SRT Viper. They started putting traction control, stability control. You're getting things like navigation in the car. You're getting things like, full leather interior. It's a beautiful, beautiful car. And it's still lighter than the previous one. They added features to the car. They added a ton of features to the car, and it's still 100 pounds lighter than the last one. So that sort of kind of throws trade-offs out the window. So you're like, oh, we need to add all this stuff to the car to comply with federal motor vehicle safety standards. Oh, it's going to add, we have to put in a computer for this, and we have to put in systems for that, and wiring for that, and it all starts to add up. But by employing composites, that sort of changes the equation, because you can still have the car lose weight, but incorporate all these features that are either mandated by the government or that are mandated by consumers. People want things like navigation. People want things like, leather interior in a $100,000 sports car. It has to be in there. This car, I'll put that right up against a Ferrari that costs 2-3 times as much. And we're getting there with composites. So what's Plasan specifically doing with the auto industry? I've been with Plasan for 5 years, and the tremendous opportunities that I've been afforded by that company, I'd be up here for an hour just listing them out, which I gotta be nice to the other speakers here and leave them some time. So what's Plasan doing? Here in Bennington is a key part of Plasan. There was a little bit of hubbub in the Bennington banner when we first announced that we were putting a facility in Detroit. The community was a little worried, and rightfully so. But PCC Bennington, Plasan Carbon Composites in Bennington, is a key part of our strategy. All of our autoclave business for the foreseeable future is going to remain here in Bennington. We're making 50% of the exterior of the Dodge Viper here in Bennington. In 5 years, I don't think I've ever seen more carbon fiber going through that factory as I've seen the past few months as we're ramping up to full production. What else is Plasan doing? I mean, other than making carbon fiber mousse, which, if you guys got to see that, oh, that was fun to work on. We also have our facility in Walker, Michigan. That's where we're focusing our efforts on higher volume production. Corvette Stingray, 30 to 50,000 units a year. In Wixom, Michigan, we have our Customer Development Center, our CDC. And that is where we tackle advanced research projects. We schedule meetings and powwows and customer days and shop tours and things to show off exactly what it is that we're doing, why we're doing it, and why it matters, and why they need to buy it from us. So I know, why are you talking about Michigan? This is supposed to be about Bennington. That CDC, that Customer Development Center, directly enabled the business here in Bennington. The fact that we were so close to our customer and able to close the loop and feed back tightly to them enabled us to bring the business back here and fill up our autoclave. We are pretty much pegged out. We're running 6 days a week, easily, every week. So the business is here. It's now. So here's a little bit of eye candy for you. I'll talk a little bit about the cars. The SRT Viper, 50% of the exterior of the vehicle is made out of carbon fiber. We're talking the hood, the roof, which is rollover compliant. Chrysler actually almost broke the machine that they used to test that roof, just trying to crush it. And also the liftgate, which is sort of like a picture frame, and then they bond the glass into that. So what does that mean? It means, look at where we took the weight out of this vehicle. The hood, the roof, the liftgate, top half of the car. You're lowering the center of gravity of the car. You're making it handle better, right? You're also improving the weight distribution front to back. I don't know if anybody's driven a Viper. I've driven one of the first generation Vipers. Oh man, was it a handful. Thing wanted to step out, oversteer, power slide, you know, the clutch was an on-off switch. This is totally different DNA than the original car. This is a world-class supercar. Let's talk about the Corvette. This is my favorite picture. It shows all the Corvettes from 1953 all the way up to now. The Corvette Stingray. This is coming out of our Walker plant. The hood and the roof, carbon fiber. When I first started at Plaisson, when it was still part of Vermont Composites, we were doing special edition cars. Corvette Z06, ZR1, the up option, the up model packages, you know, the fancy, I have a bigger hammer than you have cars, you know, the ones that the people paid extra for. That's the base model car. We're putting carbon fiber on every Corvette. Every Corvette. And it's only $6,000 more than the previous generation of the Corvette. So you can kind of see what we're doing from a strategy standpoint. Here in Bennington, we're pushing the limits of what you can do with the material. We're making the biggest composite, the biggest carbon fiber parts that are going on a vehicle right now. We're doing, you know, safety structures, rollover structures. We've got a lovely engine brace that goes in the Viper that's a structural component that changes how the vehicle handles in a corner. It makes the chassis stiffer. So we're pushing the limits here in Bennington, but we're also pushing the limits across the country by pushing how many we can make, how quickly we can make it. And we're learning things out there, we're learning things here, and it's making the company stronger as a whole, and it's advancing the state of the art for the automotive industry and for composites and for lightweight components. Thank you. Next up, we have...
Right to Ted here, James.
Ted.
Thanks for that warm introduction, James.
Sorry about that. I was reading the form and I got kind of...
Thank you very much, James. Well, I'm Ted Brady. I'm a field representative for Senator Patrick Leahy out of his Burlington office. And the senator sent me down here, and Peter and the folks at BCIC invited me down here because the senator believes, thank you, Peter's ultimate helper. The senator believes that that there's a real there when it comes to the composites industry down here in Bennington County, and that there's some great potential. Before going any further, though, I did want to mention Megan Sullivan's with us from Congressman Welch's office, a great partner as well. So if she hasn't been recognized, now she formally has. You know, the whole idea behind the Composite Cluster Initiative that BCIC, the Department of Labor, the Southwestern Vermont Career Center, and CCV are working on here is trying to create jobs. And you hear people say all the time that the public sector can't create jobs, and that's spot on. But what we can do is marry public policy with private drive and private trends. And what CMON and what Plaisson, both divisions of Plaisson, are doing here in Bennington County needed that kind of marrying. And that's what BCIC and the workforce development folks in this county came to try to do, which is to marry public policy with the private initiative. What we see happening here, the composites industry is growing. It's growing nationally, it's growing internationally. James did a great job, he always does, showing what they're doing at Plaisson to demonstrate that. But you need to understand nationally, whether it be cars, whether it be military, whether it be medical, you go down a long list of things. People are transitioning from iron, wood, steel, you name it, to lightweight, more durable goods, which fortunately we produce right here in Bennington, Vermont. In Congress, every year, the budget of the federal government comes forward, and each agency within there is trying to identify energy-saving methods. The Department of Commerce has composite initiatives. The Department of Defense has composite initiatives. The Department of Energy has composite initiatives. You just heard James. Indirectly, the Department of Transportation, indirectly actually, has composite initiatives. It's a real growth area for folks, and we need to marry the skills of the people in Bennington County with the potential. Now, I want to stress, we all know that the composites industry in Bennington is not the only industry that needs this kind of training. Every time whether it be Senator Leahy, Congressman Welch, the governor, when we're on the road, when you walk into an employer, rarely do they say, we're overwhelmed by the number of qualified people coming in the door to look for work. Companies cannot find enough people, whether it be in the composites industry or whether it be in other automotive industries, whether it be in the healthcare field, whether it be in the regular CNC manufacturing. They cannot find skilled people. So it's initiatives like this that will bring forward true economic opportunities. So I will leave it there and just stress once again the real there in what BCIC and the partners here today are trying to do. We can move this composites industry, Plazan, Command, others, and help enable them to grow, create more jobs, create more wealth in Bennington County and across the state of Vermont through this initiative and similar initiatives. So thanks for giving me an opportunity to speak. And I think my job is now to give an introduction to Jim Sharkey from Command Composites. Command is doing incredible things for Bennington County. They really are the cornerstone upon which this whole idea was built. How many years ago did Vermont Composites?
Vermont Composites was 1996, but the business has been in town for 40 years.
So the cornerstone, the visionaries,
that
40 years.
Slide, so.
Yeah, sorry, Jim. Thanks.
Thanks, Ted. Seconds. Okay, as Ted said, am I okay standing here? As Ted said, my name's Jim Sharkey from Command Composites. I say this is a brief history of Command in this area. The business started in 1973 as Oak Fothergill, based in Hoosick. 1983, 30 years ago, it moved to Shields Drive in Bennington. 1988, the company was acquired by Courtaulds, a big UK-based multinational materials and chemicals company. 1996, Vermont Composites was formed in a buyout from the parent company, and Bill Berg is here, one of the founders of the company back then in 1996. 2005, we expanded the business into the old Bezier building on what is now Performance Drive. 2006, we had our automotive division, as James alluded to earlier, and we sold that to Plazan, and that became the basis of the Plazan businesses here in town. And then finally, the final change, in 2011, the company was acquired by Command of Connecticut. Command Corporation has two divisions. They have an aerospace division and an industrial distribution division. Company sales about 1.6 billion at the moment, just under 5,000 employees, headquartered in Bloomfield, Connecticut. They have divisions all around the world, North America, Europe, the UK, and we have a sister company in India now. There are 5 businesses in the Composites division. We have a sister company in Wichita, Kansas, Bloomfield, Connecticut, in the north of England, and then the recent addition is in Goa in India. So Command's plans for Bennington, our strategic plan through 2017 is to grow the business by 50% here in Bennington, on the Bennington site. We, up till now, we're roughly 30% medical products, medical imaging products, patient support systems, components that need to be transparent to X-rays to be used in CT scanning machines, for example. The rest of the business is aerospace, 70% aerospace. Predominantly at the moment is defense related. We see the real growth area in the coming years in the commercial aerospace side, both in aircraft themselves and in aircraft engines. We see ourselves as being a major subcontract supplier to the big OEMs, the Boeings and the Lockheeds and the Airbuses and GEs of this world. Currently, we employ 190 people in Bennington. It's been reasonably stable there for a while, but to hit our growth targets going forward, we will definitely be increasing employment on site. One of the reasons we see that, we see forecast demand for carbon fiber products. I don't know if you can read that very well, but significant growth. We're in a period of growth which is probably approaching 18% growth, annual growth in the carbon fiber business. It's forecast to slow down a little bit, but it's still significant growth over the coming years. Something else that's interesting, I don't know if you can read this slide. This was in last week's Wall Street Journal. It's a slide which shows the relative manufacturing costs of different countries in the world. The United States is here as 100%. Europe is significantly more expensive than the United States. China is rapidly catching up at 93% versus 100% for America. European countries are approaching 120% cost of the USA. Mexico's down at just under 90%. Japan's 113, Italy's 119. So we're actually seeing customers coming to us from Europe that want to do business in the USA. A couple of reasons for that. One is the fact that, believe it or not, the USA is cost competitive in today's market compared to a lot of countries. And the ones that people think of as being low-cost countries are catching up quite rapidly. The other thing is the aerospace business is priced in dollars. If somebody goes to buy an airliner, they pay for it in dollars. If somebody goes to buy an aircraft engine, they pay for it in dollars. So the foreign companies have a natural hedge in buying product or subcomponents from a US supplier. So we see good opportunity for growth in aerospace in the aerospace commercial sector, and we see that as being our main way forward to achieving our strategic goals. So, and that would be based here in Bennington. What do we do? I think James described it well before. I mean, we like to think of ourselves as we sell lightweight. And then on our other side of our business would be X-ray transparency. How do we do it? We make products from strong but low density raw materials. And I have some show and tells here to show people. This is a cubic inch of steel. It weighs about 4.5 ounces, about a bit more than a stick of butter. This is what your car's made from. This is the same cubic inch of aluminum. This is what most aircraft are made from these days. This weighs about, what's this weigh? It's about 1.5 ounces. So significantly lighter. And this is the same cubic inch of carbon fiber, which weighs about 1 ounce. So that's the significant difference in the material. That's what we're selling. That's why the Corvette, the Viper, and other things are so much lighter, but equally strong. Okay, this, I really didn't want to turn this into a huge PowerPoint presentation, but I went online. I went onto the Department of Energy's website, and they have kind of a neat page here on energy.gov. It says 9 things you didn't know about carbon fiber. So number 9 sometimes known as graphite fiber, strong, stiff, lightweight material, has potential to replace steel. Okay, maybe you knew that. But carbon fiber was first invented near Cleveland in Ohio in 1958. So, good to know. But it wasn't until the manufacturing process was more fully developed at the Royal Aircraft Establishment near London that it became a commercially viable product or material. Current methods of manufacture are slow and very energy consuming. And one of the projects that Oak Ridge Labs have in Tennessee is to take and make carbon fiber from bioproducts, lignin, a wood product. Currently, the bulk of it comes from petroleum, so moving to a wood base would be a good thing to have. They have a 42,000 square foot facility down there, and they're actually producing carbon fiber at the moment from wood, from lignin. Most common precursor comes from petroleum, as I said. Goes through several processes, high temperature processes, high energy processes. Can be woven into a fabric, can be built into motor cars, airplanes. As James said, the next generation of cars could reduce weight by up to 50%. You know, I don't think they're quite there yet, but they're heading in that direction. And then in addition, it has many other uses in wind power and other industrial applications where lightweight parts provide benefits. So that's you can look that one up. It's on the Department of Energy website. Carbon fiber production process. This was a kind of a neat picture that I thought it's actually a Taiwanese company, but it takes the whole process, if I walk through it, from crude oil, breaking the crude oil down into naphtha and light oil, goes to propylene, goes to acrylonitrile, then to polyacrylonitrile. It's oxidized, produces oxidized fiber, and then carbon fiber. So it's a chemical process. It's a multi-stage process, and at the moment the precursor is petroleum. Although there are, as I said before, there are people working on other precursors. This is a little bit of chemistry, but the real takeaway from this is it starts out as a white string that's not very strong. It runs through these various processes, and you end up with a black string that is very, very strong. The first process is to do oxidization. It produces oxidized tan. A lot of the material actually stays in that state and is used for ceramic brakes. It goes into brakes in aircraft and racing cars and other things for high performance brakes. And then if you continue the process, very high temperature, 3,000 degree production process, you end up fully carbonizing the material, and you end up with this hexagonal structure, sheets like honeycomb that are then wrapped around each other to provide very thin fibers or very strong thin fibers. There'll be questions later. We use the fiber in what we call a pre-preg form. Other companies, vendors of ours, take the fiber on creels, run the fiber through a machine, apply resin to it. I have a sample here. This is called pre-preg. It's strips or strings of the fiber. I can pass this around as well. But, this has resin applied to it. It's slightly tacky, and the resin's cured. So that's our raw material. And as James said before, he hasn't seen as much of that raw material going through the Shields Drive factory as in his memory. So this is our basic raw material. I thought this was another interesting slide. It just shows who the suppliers are in the industry. Really 5 or 6 big suppliers, Mitsubishi, Toho, Toray. They're all Japanese companies and certainly represent the bulk of the suppliers. But a huge portion of their manufacturing is actually done here in the USA, so they have big facilities in the USA. Zoltec's Hungarian, but they have huge factories in Texas where they're producing material. Hexcel's a UK-based company, Cytec's American. But the market is split. Several suppliers, but not a huge number of suppliers at the moment. how do we make material, or how do we make our product? We take the raw material that's passing around here. The resin in it is already catalyzed. If you left it at room temperature, it would go hard on its own. So we actually store it. It's a perishable material. We store it in the freezer. So we take that material, sheets of material, we cut it into jigsaw puzzle pieces. Plies are placed by hand in a mold tool. They go in a vacuum bag in an autoclave for pressurization. I couldn't bring a real autoclave, but it looks like this. It's much larger. But, that's our autoclave. And then the part's demolded, and it's machined and turned into the final shaped part. Process at the moment is very labor intensive. It's very a hand process. It's almost a craft at the moment. So a lot of the effort going into the technology and the process is to bring levels of automation into it and to increase production, reduce the labor content. It's very much a craft. We are introducing some new technology. This is something that we use at Command. It's a laser ply projection system. It's basically, if anyone's ever used a laser projector to hang a picture on the wall and get it level, this is a three-dimensional version of that paints a line in laser on the mold tool to tell the operator where to place the ply. And then they press a button and it tells them where to place the next one. So that's a level of technology that we're moving to. Other processes are press molding processes, where instead of taking thin plies of material, you take a bulk material, a dough type material, and press it into a shape. This is an example of a part that we make. This is a carbon fiber part that's been press molded. Other techniques are to use a resin infusion technique. Instead of an operator laying the pre-preg material into a mold, we actually lay dry fiber into a mold, close the mold, and then inject the mold, inject the cavity with a resin system. So we've dabbled with that at Command, but it's a potential lower cost, more automatable process. Thermoplastic composites is another thing, and I'm just going to pull up a quick slide or a presentation. Hope this will work. Okay, this is an Airbus. It's showing some processing of a composite material. Instead of using a thermoset resin, which is a resin which when you heat it becomes hard and will never go soft again, this is using a thermoplastic material which when you heat it, it becomes soft. When you cool it down, it becomes hard again. And if you heat it up again, it will become soft again. Beauty of that process is it can be done very quickly. This is a robotized process showing taking a piece of thermoplastic material, essentially melting it, softening it, moving it into a press. Pressing the part. So this is a process here. It takes a few seconds or a couple of minutes. Our production processes take many minutes, 3 hours, 4 hours, 5 hours, something like that, when you include the time in the autoclave. So this is a technology that we're looking at going forward. So levels of automation, changing some of the materials.
How do you stabilize that?
Beg your pardon?
How do you stabilize it after you?
Once it cools. Once it cools.
What if it gets warm again?
Oh, this is hundreds and hundreds of degrees. This is this is it's 700 degrees Fahrenheit, something like that. It's not you leaving it in the sun won't.
No, I didn't know in aircraft or in military applications how warm things would go.
I mean, you wouldn't use it in the engine, for example. Bring my slide back. So that's an example of new materials, new processes that we're looking at and other people in the industry are looking at. Aircraft trends. This is a little picture out of almost a kid's book, but these are the 4 forces on an aircraft that keeps it flying. There's the weight of the aircraft pulling it down. There's the lift of the wings pulling it up. There are a couple of main drag forces on the aircraft. There's something called induced drag. If you put your hand out the window in a car and you tip your hand, it'll push up and push back. The push back is the induced drag. It's proportional to the lift required, which is equal to the weight of the aircraft. So this is a diagrammatic way of saying if you reduce the weight of the aircraft, you reduce the induced drag. And if you induce the induced drag, you reduce the thrust that's required, so you can make the aircraft fly with less energy. So looking at jetliner and composites evolution over the last, since the 1970s, aircraft started with a tiny percentage of composite materials for covers and radomes, that type of thing. They moved up through rudders and ailerons and other control surfaces, all the way up to today, where aircraft like the Boeing 787 and the Airbus A350, they are 50% plus carbon composite material for significant weight savings, and as the earlier diagram showed, significant reductions in the energy needed to make them fly, and therefore the cost of operating them, and all the other associated things like pollution, etc. And this was last Friday. This was the very first Airbus A350 took to the air. Nicely timed just before the Paris Air Show, which was good timing on Airbus's part. But this is definitely the way of the future. Trends in aero engines, which are a big part of that. Obviously, weight savings in aero engines are a big thing. Another thing is another diagram out of a kid's book or a textbook, but looking at increasing the thermodynamic efficiency of the engines, and that's basically extracting the most amount of energy out of the fuel, or burning the fuel in the engine. There's some physical limitations to that based on the temperature of the engine. There's a Carnot efficiency equation here, and it's a real simple equation. It says the amount of energy you can extract from a heat engine, it depends on how hot the engine is, the highest temperature it can run at, and the lowest temperature that the exhaust gases emerge at. You can think of the energy being extracted from the engine. Imagine a jar of peanut butter. And regardless of the jar of peanut butter, there's always some left in the bottom that you just can't get out. And the amount of energy or the amount of peanut butter can be in the form of a small amount of peanut butter at high temperature. So imagine a long, thin jar, but you still have only got the same amount at the bottom that you can't extract. So proportionately, if you have a long, thin jar of peanut butter, you get more peanut butter out. So it's a way, having a higher temperature enables you to extract more energy from the fuel. The other trend is increasing the propulsive efficiency of the engine. So once you extract energy from the fuel and turn it into horsepower, turn it into shaft horsepower or mechanical energy, the next thing is to turn it into useful thrust. And again, there's another simple little equation that describes that. And the efficiency of the thrust of the engine depends on the ratio of the speed that the vehicle's moving through the air compared to the speed that the gas is coming out the back of the engine. And the way to get 100% efficiency would be to have the vehicle moving at the same speed as the gas coming out the back. And that would be like the fan screwing its way through the air. In reality, a jet engine stripped the threads a long time ago. It's really pushing gas out the back. But the baseline is that if you can slow the gas coming out the back of the engine and produce the same amount of power, you can have much higher propulsive efficiency. And the way you do that is with a bigger fan. So the picture here shows the core of the engine in the middle, and then this here is the fan, where most of the propulsive thrust comes from. One way to make these fans bigger is to make them from lighter materials. The fan spins at very high speeds. There's huge centrifugal forces on it. If you make a metal fan too big, it has to be very, very heavy and very strong to support the loads that applies to it itself. So composites can help there by making it lighter. The other thing is the duct on the engine also provides a containment device. If a fan blade breaks, it would fly off. You don't want it to come through the fuselage, so the duct around the fan holds any debris in place and doesn't endanger the aircraft. So lighter blades means a lighter containment device as well, and much as James said earlier, lighten components, you can lighten other components as well. This is an example of a new engine using some of that technology. It's an engine called the LEAP-X. It's built by a joint venture between GE and Safran, a French company. This uses the main fan case is composites. The fan blades are composites. Interestingly, these are going to be made by Albany International. They've just put a big factory in Rochester, New Hampshire, to make these parts for this engine. And this is the engine that will be driving the new version of the 737 and the Airbus A320. This is a diagram or a picture showing that engine. This is our component here, believe it or not. This is the little piece. So we're already making parts, so we've made some sample parts for that engine, replacing steel to help reduce the weight of the engine. It's a very simple component. It's actually a beam which holds piping and cable harnesses. This is kind of something more of interest, but these engineering's never simple. You know, there's usually a bug, there's usually something that you have to fix. But as I said before, the way to greater propulsive efficiency is bigger fans, so bigger engines, bigger fan blades on engines. These pictures here show a 737 on the left-hand side and an Airbus A320 on the right-hand side. They both have the same engines. The 737 suffers from a problem. It's got short legs. And if you look at the picture, the engine there, they had to push it up into the wings and they had to squish the bottom of the fairing to be able to fit that engine in. The Airbus on the right-hand side, same size aircraft, same type of aircraft, much more modern aircraft, room for bigger engines. So if Boeing ever want to fit a bigger engine on the 737, they're going to have to completely redesign it because it's... and the reason for having the engine that high is to clear the blue lights on the edge of the taxiway. So. Couple of quick slides to end with. This is another diagram from the news last week. It shows the percentage of people graduating in the USA compared to other countries with engineering degrees. And if you look at the USA, it's about 4% are graduating with engineering degrees. China is almost 35%. Even European Union's over 15%. So significant issue in the United States if industry and business and manufacturing is going to grow. So I thought that was an interesting chart. But here in Bennington, we're doing some things, and this is, I think, a segue into the next presentation. But this is some of the work that we're doing here with CCV, CDC, Department of Labor to do training for composites, but also for other industries. So I say that's my final slide. Thank you. I would like to introduce the next.
Brian Smith.
Okay, Brian. Yeah.
Well, I'd like to start by saying thanks for allowing me to be here tonight and talk to you about some of the things that we do at Plasan North America. If you don't realize it, we're on Bowen Road. We have two buildings on Bowen Road, and just a couple blocks from here. I was asked to talk about survivability projects that we do at P&A, and when I talk about survivability, what I'm saying is predominantly armor. Plasan, that's the core business of Plasan, is survivability. It's not just armor. They design different types of components and different things that help keep soldiers alive. But at P&A, all of our work is armor related. And so everything I'm going to show you is related to armor. The second thing I want to say is tonight, both speakers that have already been up here have talked about composites, specifically fiber reinforced plastic composites. And at P&A, we think of composites as being taking different materials, bringing them together as an individual material or as an individual system, and getting a better performance out of those materials than you would have gotten if you had used them individually, okay? So in the case of carbon fiber, you have a carbon fiber, you have epoxy resin, you bring them together, you get the combined effects of both materials, and what comes out the other end is better than either one of those individually. Well, we work with carbon fiber, of course, but we also will combine plastics with metals or plastics with ceramics to come up with a composite material that gives improved survivability characteristics to armor. So it's not just going to be fiber reinforced stuff, although we do that work as well. So the areas of survivability or where we bring survivability to the warfighter is in these four areas. Tactical wheeled vehicles, that's really the core business, but also we have a growing business in the maritime sector, and specifically I'll show a couple of examples of what we call topside structures, which are on the top deck of a ship, and below deck structures, aerospace, and of course personal protection. I guess one thing I will say, this stanchion right here, it's not made in Bennington, but it's made by Plasan. That's a composite stanchion. And that small thing right there controls the up and down of this flight elevator. It replaced a steel stanchion that used to be on aircraft carriers, the CVN, the series of, in the US Navy's fleet, and the steel stanchions would get bent because the sailors would run into them with their vehicles on the flight deck, and then they couldn't make the elevator go up and down, and all of a sudden you have a bent steel pole and you can't have flight operations. So the Navy has replaced it with a flexible composite stanchion, which is made by Plasan, just not made here in Bennington. So the first thing that you have to understand about survivability is you have to design your armor appropriately in order to keep the soldier or the warfighter alive. And that always starts with understanding what the threat level is. And it's not that complicated, really. It's about size, it's about weight, it's about speed, it's about the core material. So you have to start with the understanding of what am I trying to stop. Once you understand that, then your design becomes fairly straightforward. It's a pretty well characterized field out there. Another consideration, and you've already heard it tonight, but it's never going away, is weight. Weight is just almost always the number one thing that people in survivability are concerned with, getting lighter all the time. And it's not just the armor piece itself, but it's all the stuff that you use to attach that piece of armor to the vehicle, that piece of armor to the ship that it's on. That counts as well in your weight calculation, and always they want it to be lighter than the last thing that was there. And finally, and in this day and age, which is now the number one thing, it's always cost. Cost, cost, cost. Procurement cost is always what the buyers in the military are concerned with. They want the cheapest thing up front because somebody looked at them at the end of the year and says, how well did you do? How much money did you save for me this year? Us in the composites industry, we always are trying to say, well, okay, we're working towards reducing the price of composites, but we want to point to life cycle costs. And the life cycle is the total cost to have that composite on the vehicle or on the ship or in the airplane. Because most of the time, that is dramatically less than the piece of metal or the piece of plastic or the piece of ceramic that used to be there. And so the battle is always to get the buyer to be willing to pay maybe a little bit more or something similar to what was already there to save money in the long run. And thankfully, the military now is looking at return on their investment more than they used to, as well as the straight-up procurement costs. So these are always these are always the factors that go into all armor designs at P&A. Tactical wheeled vehicles, it's the number one thing that's done here in Bennington. Armor for tactical wheeled vehicles. The future, that's not going to change. Passive armor is what the current technology is for the U.S. and all around the world. And when I say passive armor, that means something that sits there and waits to be hit by a threat, incoming threat. It doesn't move. Hopefully it doesn't move. And it's been designed not to move. So as I've already told you, the threat is the number one concern. Weight is an absolutely important driver. It's key in everything that's done in the design. Cost, as I've already told you. Integration. Integration is what is the hallmark of Plasson. That's where Plasson differentiates itself from other armor manufacturers. The ability to design for ease of attachment, ease of replacement, to be done in the field, and to have this be an effective design overall. And that's a differentiator for us. The types of materials that are used are steel and Kevlar. All right, so that's our composite. It's dried Kevlar fabric, which is attached to steel. There may be ceramics as well involved with that, but the basis is always Kevlar and steel. The future, however, in vehicle survivability is going to be what's called active armor. Okay, and I have a little CAD rendering. If you see this funny looking frame on the top of the vehicle, that's the active protection. And what active protection is the vehicle, as it's driving along, something is shot at it. Its sensors detect an incoming threat, deploy a countermeasure to defeat the threat before it even gets to the vehicle. It sounds like science fiction, you know, it's like Star Wars, right? President Reagan started Star Wars. Well, this is Star Wars on the ground. But it's a real technology, and it's been demonstrated. Our federal government, the DARPA agency, has been working on this for a long time. It can be very, very effective, whether it's foggy out, whether it's dusty out in the desert. That's where survivability is going. However, that has many problems, and it's I would say at least a decade, maybe more away. Okay. In the meantime, passive armor is going to be there, and the drive is going to be to make it lighter and more effective. So now we're talking about the maritime theater, and I have two examples of armor that we're involved with at Plasson. This is an example of a topside armor application showing a small ship here down the bottom where this is fielded. These missiles sit on the top side of the ship, and they don't, as they sit there, originally designed just to shoot the missiles off of that launcher right there, just as you see it in that picture. The problem is now these ships operate close to shore, and more so in what they call the littoral waters, which is closer to shore. Or you have a pirate ship that pulls up beside you, they can shoot at these missiles, which are bare and on the deck of the ship, and all of a sudden you can defeat the ship, even though you're a couple of Somali pirates just in a small dinghy of a boat. So the Navy wants to put armor around that to protect the missiles and ultimately protect the ship. So we've designed the box and the armor that goes around the box that protects those missiles, which are on the top side of the ship. As I've said already, in this case, it's aluminum and polyethylene, which is a very lightweight plastic. And that's the composite that's used here. So it's a lightweight plastic combined with aluminum metal. It sits on the top deck. What's really important, and what the Navy is ultra concerned with when you put something on top of the ship, is, as you've heard already today, especially with the Viper, the center of gravity of the ship. The higher the center of gravity, the more likely the ship is to tilt over. And so the Navy really doesn't want to add weight to the top side of their ships. They want to push all the weight down to make the ship more stable. So that's why lightweight and effective survivability is critical. In this particular application, we have something that's a below deck application. And here's a missile launcher that is installed on all the destroyers in the US Navy. And surrounding the missile launcher is a curtain of armor. The first area where this is being used is a new composite destroyer that the Navy's coming up with. Their missiles are on the outside of the ship. If you remember back, I don't know, maybe 10 years ago when the USS Cole, when there was a terrorist attack on the Cole where they drove up next to the ship and detonated a bomb through a hole in the ship. Well, if your missiles are arrayed around the outside of the ship, all of a sudden, again, a very small threat comes up and can ruin the day of the ship and destroy an important asset for the U.S. Navy. So they designed the armor to go around it, and it was built by Plasan. In this case, we have a fiberglass component here, a backer board, what we call a backer board. So the same glass you might use in a pleasure boat. Different resin system though, however, resin is called phenolic resin. It has very unique characteristics. It doesn't burn. And even when you put flame to it, the smoke that comes off, it's very little smoke and it's not toxic. So if you're below decks and there is some kind of a fire, the sailors who are fighting the fire aren't going to be overwhelmed by these noxious gases coming off by the composites used in the armor. Ceramic tiles wrapped with carbon fiber. So here you have an armor where you have carbon fiber, epoxy, you have fiberglass, phenolic, you have ceramic, all together in a sandwich to protect the missiles on board. Again, it's a composite system, multiple materials giving you behavior that you wouldn't have gotten individually. Aerospace, as you might imagine, weight's another critical area. In Plasan's portfolio, it's really just helicopter work. And as you might imagine, it's underneath the helicopter. So you got to be concerned with underneath the helicopter, underneath the cockpit, and in some cases maybe underneath the seats. And now you see examples of armor on the bottom of the helicopter. In this case, again, it's polyethylene. A lot of the aerospace armor is almost always polyethylene. It's so incredibly light. Kevlar ceramic layers may be required depending on the threat level. Almost never will it be metal used. It's just too heavy and it demands too much of the airframe in order to do that. That's the way it's going to be into the future. That's just not going to change. Then personal armor is the last area we talked about. So as you might imagine, since people are going to walk around with this armor sitting on them, weight is the number one concern that they have. Of course, it has to stop the threat. So you don't even get to talk about anything else unless you can stop the threat. But once you've demonstrated that, it's got to be lightweight. The soldiers running around nowadays have so much armor on them. It is so extremely heavy, especially when they're in the desert. They're overcome by exhaustion just by lugging around all this armor, which is designed to keep them alive. But like always, I want it to be as cheap as possible, right? The federal government always wants the cake and they want to eat it too, right? So they want to stop the threat, make it as light as you can, and oh, by the way, make it cheap. Comfort is now more and more becoming an issue for the military. It's difficult to wear these vests and this armor, and now with more and more women out in the field, it's even a greater concern because the armor that works for men obviously is not going to fit a woman the same way, and it's just not safe. It's a comfort factor for sure, and it's a safety factor. And you might say, well, why is comfort important? They're going to, they want to stay alive, right? Well, it's important because they don't wear it if it's not comfortable. The soldiers are funny in that when they get into the field, if they can't run or dive or dodge, they're not wearing it. So even though I could take a strike on my chest and stay alive because I'm wearing armor, I don't even want that. So if I can't move, if I can't dodge, if I can't get down, I won't wear it. And so it has to be something that's attractive to them to wear, and that starts with comfort. The threat levels that the military is concerned about, it's actually quite a large range of things. armor piercing included. So you got to be worried about that. The ceramics are the key part of the survivability in body armor. That's what defeats the threat. The composites or the polyethylene core catches the fragments after the threat has been broken up by the ceramic. One of the areas that seems to be growing is metal matrix composites. So that's where you have a metal matrix and you have a second feature that's in the metal matrix, whether it's a ceramic feature or whether it's a fiber or something like that. And it seems like more and more that we see metal matrix composites are becoming important for personal armor protection. And one other thing I might note is that flexible armor pictures here, it's a Poisson product. It remains to be seen how much that'll be used, but it sounds like it would be a comfortable thing. It is effective at stopping the threat. It's just more expensive right now than the military cares to pay. That's it. The final thing I want to mention to you, and this is another aspect of personal armor that we're working on in Poisson. This is the classic photo from the movie Hurt Locker. And although we don't make the suit, we make a couple of the armor inserts that go in the suit. And I had this picture in to key my memory to tell you, when we talk about threats and survivability, the number one thing is a bullet being shot at you. But the second most important thing is a fragment. Now, it might be a bullet that hits something next to you and fragmentizes, or it may be an explosive device that throws fragments into the air. And so you have to stop the fragments just like you have to stop a bullet. So it may not be a direct impact on you, but a fragment can drop a soldier just as quickly. So that's the point of this bomb suit, is you have to have some fragment protection. And that's what we make at Poisson. Here's a couple of examples. In this suit, there's one of the fundamental parts of the survivability in the armor in the suit is this chest panel and a groin panel. And in both cases, this is just polyethylene. All right, that's a singular material. But when it's delivered to the manufacturer of the suit, it's combined with other materials to give the protection level that's needed, so to add the survivability aspects from fragments on the suit. I think that's it. Again, any questions? So again, I say to you, when you think about survivability, cost is key. And that's where the federal government's always most concerned about. We at Poisson are working with multiple materials, bringing them together, giving new types of survivability products, new types of armor products to give the warfighter what he needs to stay alive.
Next up, we have Marie-Pierre, Jeannie, and Melanie.
Thank you. As we're getting set up, just let me introduce myself for those who haven't had the pleasure to work with me. My name is Marie-Pierre Huguet, and yes, I'm from France, but I've been here forever. I love Bennington, and I'm still the new assistant director for adult education at the CDC. Give me another 3 weeks, it will be my first anniversary, and then I can't use this as an excuse for making mistakes. Thank you. Yes. I have a very short presentation, so don't worry about it. But I did create a few slides to just remind myself of what I wanted to talk about.
It's not on the screen.
It's not on the screen. this is so unfair.
Yes,
You know?
this was working before.
Yeah,
wasn't it?
we tested before, we made sure it worked. Yes, I'm going to have to add this.
Something's happening.
Yeah.
Yeah, there we go.
So for those of you who don't really know what the CDC is, it's a wonderful place that, even though I've been living in Bennington more than 20 years, even I didn't really know that. We are a technical school, and we have day programs, about 20 programs running currently, but what really matters to today's topic in the composites is that we have 2 programs, design and fabrication and engineering and design, and actually some of you are on the advisory committees, and we are training the next generation of employees that will come and work in some of the local companies. But we also have, as you can see, a program. We have an adult program, and what I did, I brought a few handouts for those of you interested in what would specifically apply to manufacturing, and my colleague has them with her. Yeah, interesting. So, very brief history, because why is the CDC here? Isn't that some sort of a high school where people go and learn how to cut pieces of wood? Well, it's more than that. It really is a lot more than that. So in the fall of 2010 or something like that, the BCIC had a report done, and it turned out we need to train our workforce. And where do you go? Well, you can come to the CDC, you can go to CCV, and Jeannie will talk about that a little later, or you can work with the DOL, and Melanie will address this component. So it is not just one place where you go and everything gets done. It's really a collaboration. And we got a grant to start an amazing project, and all these companies got involved, and I hope I didn't miss anybody. It was a little before my time. But coming in, seeing the commitment from the USDA, from the state of Vermont, from the local industry and companies really blew my mind and made me very proud of what we can achieve in Bennington when we put our collective minds together. And we even had someone go to, and that was Brad, who went to Utah to work with a college that already was doing something similar. So our composite program has gone through various versions, and currently as it is, we have, as one of the predecessors, precedent speaker mentioned, we have the manufacturing core, and we have 3 courses: blueprint reading, inspection and measuring tools, and then quality manufacturing. And these courses can go and apply to all manufacturing industries. And then we have, and each is about 15 hours, and then we have the composites core. As it is right now, we have 2 major components, each of 45 hours. And we had a meeting last week, and we discussed the future of the program, because we're just finishing the USDA grant. We are going to have to be self-sustaining. We have to make sure that we serve the community, not just in Bennington, but in Vermont as well. So as we move forward, what we are going to do, what we intend to do, is actually start working towards maybe splitting these 2 45 hours blocks into 3 blocks, so that it's more manageable for your employees when they come and need the training, and they can't pack all this time in here. But we're also talking about going blended, where we split. We have the online component where you do the theory, you do the reading, you do the boring stuff in some cases, and then you come to the CDC where you can actually do the hands-on. We have, through the grant, got the equipment so that you can actually do what the speakers were showing you and talking about. And if you have any questions, we actually have Brad, who's here and teaches the basic class, and then you heard from James, who teaches the 2nd level. And somebody asked me a really good question. They said, well, why would people come to the CDC Well, it's because the people that teach classes in the manufacturing section, they all come from the local companies. We have people from Plossant, Command, Energizer, JBM, Sherman Carmel, Vermont Composites. We have the people that actually work in these companies that actually come and teach other employees or men and women who actually want to learn more. So I'm going to stop here. I brought some handouts that we can leave on the table over there, or you can get from my colleague. And you can always call me if you'd like. And I'm going to let Jeannie come and talk to you about what she has brought to the table. Thank you, Jean. Thank you.
So hi, thank you. So I'm Jeannie Jenkins. I'm a coordinator at the Community College of Vermont. And I also want to reiterate, I think it's really great that Peter is having Marie-Pierre, Melanie, and me speak, because I think we are really fortunate in this community that service providers, education providers really work together well. We offer three paths into composites and also into engineering tech and just STEM area. And I think that what we are very good at doing is helping an individual with whatever they need. If what I can offer at CCV is not what they need, I'm going to send them to Marie-Pierre, I'm going to send them to Melanie at the Department of Labor. So know that you can use any of us as an entry point, and we will make sure that you do get what you need. I think the statistic that 62% of jobs now require some education past high school is something that we all know. It's something we're struggling to make sure that we are making clear to high school graduates, and that we are helping individuals get the post-secondary ed that they need. I think it's interesting that the number of STEM jobs, the growth in STEM jobs in Vermont matches the increase in composites jobs in the state as well. So this is clearly an area of growth. We've had an 11% increase in STEM positions in the last 5 years in Vermont. So there's no reason to think that that is not going to continue to grow, and probably grow at a faster rate. And so this is actually good news for us. And what I want to share with you today are four areas where I think CCV can be of assistance in this growth. The first is we have a program called Career Ready Certificate, which helps individuals who need to assess their academic skills, math, writing, speaking, who also need to look at their presentation skills, whether it be in written form in terms of resume, or whether it's interviewing skills, and also for them to do some career exploration so that they can look at where they are now and where they need to go. Is it going to make sense for them to enter the composites coursework that Marie-Pierre offers? Do they need to do some basic skills work in academics before they move forward? Do they need to be looking at other aspects that before they move forward? So that the Career Readiness Program has been of great assistance, particularly to people who are changing careers and folks who have lost positions and are trying to rethink how to talk about their skill set, what their transferable skills are, and really move themselves back into the workforce. The second area where I think we can be of great assistance is focused work on math. We actually work with a lot of employees of the composites industry who may be very expert at their particular task and use math in a very focused way, but have very little understanding of how what they do actually fits into the bigger picture of math. And so that their ability to move from the position that they're in and the job that they're doing into something else is limited because they don't know how things connect. So we will work with individuals. Obviously, they can take courses, but the other thing that we can do is come into companies or work with individuals at CCV and do basically self-paced learning where there's a coaching component. So we will work with individuals as they're building the individual math skills they need, and then work with them individually to make sure that they understand what they're learning and move to the next step. And I think that is something that we are happy to take into the business environment, into the manufacturing companies, and and help you with that. I think this will be particularly a benefit as you want to grow the workforce and you want to take the employees that you already have and allow them to move into new positions. The other two ways that I think we can really be of assistance is we do specialized training. This past year, we have been and are working with 40 employees at one of the composites companies to build supervisory skills. And I think this has been really important because it allows individuals, again, to be ready to move up in the company rather than having to hire employees from outside. You can grow your own, and that's good for all of us. The supervisory training we've been doing has two components. When it has a classroom component, but the bigger piece of it, again, is individual coaching within the company, so that individuals are taking the skills, are taking the theoretical knowledge that they're learning in the classroom and then applying it for several weeks, then moving into another key concept and applying that in the workplace. The fourth area which I'm very excited about, as many of you may know, Community College of Vermont really was founded as a liberal arts institution, and one of the things that we've always struggled with is not really being able to offer the kinds of math and science that clearly today's world needs. And so in January, we are launching a STEM associate degree program, which has 3 tracks: engineering, physics, and engineering, biology, and math. And so individuals will get a large amount of coursework that would allow them to either move directly into a bachelor's program in engineering or biology or physics, or to move into engineering tech programs. And so this program has been developed largely looking at UVM and Vermont State Colleges as its partners, but I'm quite certain that it's going to nicely dovetail with institutions we have just over the border in New York State. So that that's something I'm very excited about, and that's going to allow individuals in this community to access math and science in a way that they have not been able to before. As we all know, Hudson Valley is the closest place to go to get that kind of education and training at this point. So those are the 4 things that I think we can offer, and and I look forward to working with you on it. I did bring some materials. I brought my card, and I'm happy to talk with anyone afterwards. And with that, I'm going to turn it over to Melanie Letourneau.
Good afternoon. Thanks for hanging in there. This has been kind of a long afternoon, but we've learned an awful lot of information. I'm Melanie Letourneau from the Department of Labor Workforce Development. It's kind of a mouthful. We just call it VDOL. And it's kind of fitting. Number one, I was one of the people that was originally responsible for Oak Fothergill. Remember that? Way back in the 80s? I'm going to tell you the story just really quick because no one else has told you any fun stories. Back in the 70s, when they were in Hoosick Falls, New York, we used to, as neighborhood kids, go down and steal all the Teflon, all the leftover materials, and we would ride down this really big hill on them and usually crash into the engineer's car the guy that owned Oak at the time. And I think that because we did that for so many years, that's why he moved to Bennington. We were always blamed for that. The major theme today that we've been talking about is we've been talking about the composites, about what the training programs are, but the baseline of that is in order to make this work, we need people. We need to have people that are geared up. We need to have people that are applying for these positions. And the good news is that the unemployment in Vermont is down to 4.0. Did anybody see the April 2013 results? That's a really great thing. We're one of the lowest states and counties in the country as far as unemployment goes. The bad thing is the unemployment is down to 4.0, which means that there are less and less employees that are available to hire. And right now, with all of this great turnover, all of these new people being needed, we really need to get resourceful and creative in how we hire and who we hire. And that's where the Department of Labor comes in. We work with 100% of the people, 100% of our time. We work with unemployed people. We also work with people who are underemployed, and we work with people who are unemployed, underemployed. A new category of individuals has emerged in this new economic downturn, are the overemployed. I don't know how many people come into my office and they're working 2 or 3 jobs trying to make ends meet, and they're looking for one full-time position. So the people and the activity is there, and it's our job to help match it together, to help encourage them to go and get training if that's what's needed, to apply for the positions. We can help as far as career exploration goes, help people write their resumes, practice their interviewing skills, kind of come up to speed to the level of what the companies are looking for. But we can go a little bit further than that even every day. We talk with employers. We help employers as far as what is their HR departments doing. Are they looking for the right people? We help match them together. So we're conversing on both sides all of the time. We have funding available. The initiatives from the governor's office is really helped out as far as the Workforce Investment Act. We can help with WEP funding if you're an employer. We can help with on-the-job training programs, with work experiences, with just actual classroom funding, whatever really individuals need. If we can't do it ourselves in our office, it's our job to find out who in the state does it. We're really fortunate in Bennington to have such a diverse group. We do have Hudson Valley close by. We also have Stratford up in Rutland, which is producing some quality mathematical people, engineering type people. We have people that are interested, and I think that we are really kind of going in the right direction with a lot of stuff. If you're an individual looking for a job in composites or you're looking for training, please call us. Call any one of the people that you've heard from today. But call us, and we'll sit down with you. We'll make an appointment. We'll look at what your resume says, what your education level is. We can do a career assessment in just a few minutes. We can check your math and English skills. We can guide you to the next step. I think that's what the Department of Labor does the best. And with that, I'm going to keep it really short. I know everybody's really getting tired, and I thank you very much for your time. Peter?
Peter Odierno with BCIC. First of all, I'd like to thank our sponsors again. I'd also like to recognize the support that we get from our local delegation. I see Bill Botzow and Mary Morrissey was here earlier, and certainly Dick Sears has been a huge supporter of regional development across the state. Even though we are deeply involved with all these companies, I learned a whole bunch of new stuff today. And I think what it reaffirms quite clearly is we have a unique opportunity here. And I think it's our responsibility as a community to recognize that and plan accordingly. Because as Melanie did say, our unemployment rate is low. On one hand, that shows progress that we were able to withstand the recession pretty well. But on the other hand, the availability of people who have skills to enter the workforce is relatively low. And that's what we really need to focus on. And as exciting as Kaman and Plasan Carbon Composites and Plasan North America, I think the efforts of Melanie, Jeannie, and Marie-Pierre are going to be central in terms of our ability to capitalize on this unique opportunity. So we do have time for Q&A. If anybody has a question, please step up to one of the mics and shoot away.
I do have one based on some of the things Brian was saying. My understanding from what I'm seeing is that the carbon composites at this point need something to make it affordable, such as energy consumption. For instance, if I have a piece of equipment that's cased in wood, it doesn't make sense to just change that to carbon composites unless I'm shipping it all over creation, and that cost savings would justify that. It seemed like, in the armor, when it's passive armor, the carbon composites doesn't come in. When there's fuel consumption, such as an aircraft, that seems to bring that into an affordability standpoint. Is that accurate, or?
Yeah, I think generally that is it, somebody came up with a figure of merit that what people are willing to pay for. So the satellite guys, they shoot things up, 25,000 feet and above, they're willing to pay thousands of dollars to save a pound. The aircraft guys, which are, from the ground to that level, they're willing to maybe spend $100 to save a pound, where the automotive guys are willing to spend less than $1 oftentimes to save a pound because of the volume and the magnitude of what they're trying to do. So as James said, BCC's done a terrific job at trying to develop low-cost manufacturing to bring composites to the masses, because in the automotive industry it's so important, the cost is so critical. But the other factor, as us composite guys are always trying to drive home, is the return on your investment, the life cycle cost. So corrosion doesn't happen in composites like it does to a lot of metal structures. Oftentimes they're more robust than the ceramic structure, and you don't have to paint them and all these kinds of things. And so you try to appeal to somebody's life cycle cost, because you have to pay for it as long as you own it. It's not just procurement. So I think the other guys want to address that.
Plasan Carbon, we're constantly trying to improve our cost ratios on products. I'm happy to say, and this is something that we publicized when we won the award for our Viper hood. We actually won an innovation award for it. Part of the reason we got that award is for a given surface area, we're actually making composite assemblies 40% cheaper than we were 5 years ago. So that's a dramatic cost savings, and that combined with our next generation lower cycle times. We're talking about our autoclave turns every 90 minutes, 100 minutes, but our next generation process 17 minutes. We actually have to slow it down to match the flow in the rest of the factory, and we're driving to 12 minutes, and then we're going to go to 8 minutes, and that is how we're going to end up doing, and I'm just pulling something out of the blue here. That's how we're going to end up doing a Honda Civic hood or a Ford F-150 hood, something that's going to have hundreds of thousands of vehicles a year.
Is there an immediate demand for manufacturing employees here for all these companies, Plasan and the rest, or just like a future kind of we want to ramp up production in Bennington and we're trying to train more people so we can ramp up, or is there just a immediate demand that's kind of slowing down production?
Well, as James indicated earlier in his presentation, you running 3 shifts now, James?
Yes.
6 days a week?
5, 6 days a week.
A couple of Sundays ago, I drove by at 7:30 in the morning. Don't ask me why, but I did. And the parking lot was full, and I think that underscores the fact that Plasan Carbon Composites has grown tremendously over the last 2 years. Jim, I think that you guys are always looking for talent. Is that safe to say?
We are, yeah. I mean, we're handling turnover mainly at the moment, but with our future growth targets, we will be hiring more people. Yes.
Yeah.
At PCC anyway, key positions we do either through headhunters or LinkedIn and that kind of thing. For manufacturing, we hire through Adecco, and after a certain period of time, I'm not an HR person, so.
How many people actually get placed out of like CCE and go through those programs? Do you know with that?
Well, we're at healthy employment levels right now in terms of the composite companies. K&E Plastics recently expanded from Arlington, moving from a 12,000 square foot facility into a 35,000 square foot facility. We continue to work on other supply chain enhancements at BCIC. And I can't make a blanket statement, but what I can say is if you've got an engineering degree, if you've gone through a program at the CDC, if you've gone through the career readiness program, you're at the top of the line. And
I just want to make sure the companies are getting what they want from our county as opposed to like moving somewhere else where they can get a larger talent pool.
well, certainly access to skilled labor is going to be the biggest challenge that we have here in Bennington County. I mean, if you look at our population data, for instance, it's been stagnant for 40 some odd years. I mean, the state population's been the same, our local population's been the same. We're at full employment, close to being at full employment. We have no empty industrial buildings. And when I said it's incumbent upon us to recognize this unique opportunity and plan accordingly, that's what I'm addressing. And you hear anecdotes all too frequently about a recent graduate from, I think Brian mentioned a number of states, Iowa and a couple others, who are coming to our community to accept these positions. And that's going really well. Where it reaches the bottleneck is where they look for a place to live. And so...
Professional positions as opposed to manufacturing positions.
Mm.
And I'm hoping that our high schools and our community colleges are teaching our local students
Mm-hmm.
talent and skills they need to provide a pool for the employers to fill up the manufacturing positions.
Yeah. Well, I think one of the takeaways is, you know, the recession that we all went through from 2007, 2010, 11, whatever you want to call it. There were actually very few opportunities to actually grow jobs. So we worked really hard with the companies that we had to make sure that, you know, to the degree that we can, we're helping them navigate this recession. But we also said at some point in time, this is going to end. And when it ends, the priority is going to be access to skilled labor. That's why the program at the CDC is relatively new. That's why a lot of the stuff at CCV is relatively new. That's why we launched what I thought was a really cool concept earlier this year, which was Career Week, where we had 50 professionals at Mount Anthony High School addressing the seniors during that week. And so we're doing stuff. A lot of it's new, grassroots, and innovative, and it's going to take some time to see that return on investments, but it's happening. And clearly the common theme amongst the presentations here was there are unique opportunities for these guys to capitalize on this theme of, you know, mass reduction, grow their businesses, and grow their employment base, and that's what we really have to prepare for. So we're all working hard at it.
I might add, so as Director of Engineering, I'm currently trying to, along with Kathleen, my HR Director, trying to recruit professional positions. But I've actually had a couple of examples in the last few years of individuals who are working in production that want to transition into a technical role. They're high school graduates, they're talented kids. They're sharp guys on the floor. They've been identified by their operations manager and given more responsibility because they're intelligent and they are responsible. So they're in our group, and we're training them on the fly, so to speak. When we come to the end of the year, we have the performance evaluation, and it's a simple message for me every single time. I understand you want to grow with the company. I understand you want to make more money. But this is an engineering organization. You don't have an engineering degree. What are you doing about that? Well, you know, I could do it online, you know, but now I hear there's a local opportunity that's incredibly important. So that's the thing, you got to challenge them to get those degrees, but it's difficult because you're in your life, right? You got things you got to pay for, you got to set like go back to school. But if it's local, now all of a sudden there's no excuse. Hey, listen, you can go across town and get that, or you can go to the next level. It's different, and I think that's the most important thing I heard tonight was that, because we know we have a few individuals that are looking to us to help them grow, and I'm looking right back at them, so you got to get a degree, man.
Are there any metrics coming out of the community colleges placement experiencing after completing the program?
Well, the STEM program hasn't started yet, so
No,
there's
but
nothing
like,
in there, but,
But there was a manufacturing programs for,
so the bulk of the individuals that have gone through the first year of the composites manufacturing program were incumbent workers, right?
Correct.
So that the data on that is, I mean, Brad, they did well, you know, I mean, yeah.
The feedback we got was really, valuable to us. What
incumbent
is-
workers, then they're already working at the composite industry and they're just
Correct.
improving their skills.
Correct, and we had a few underemployed and unemployed people join the crowd, but it was harder for them because they also had other classes and other courses that they needed to take to really be able to function in a factory environment. So the next generation, the next group that's going to start soon, that's going to, for us, it's going to provide us with a lot of information that we need as to how is it that we need to work with them? Is it, what kind of issues do they deal with? Is it, do we spend enough time on the hands-on, for example? Or do we need to push them a little more towards the computer classes? Or do we need to teach them how to just interview? So you have all these various skills that come into play that because we work together, we do share the information. And that, when we see someone really leaning towards ending up as an engineer, we push them towards CCV, and we have a couple of cases that, came out that way. Or vice versa, when we realize, you may not want to go for a college degree, but more than you want a training background, some skills that you can really use, then they come to the CC. So it really is the collaboration that's a huge.
It's interesting, it sounds like they're all incumbent to be able to get like kids, students, or adults wanting to take that composite program.
We have two groups, we do have the day students, and some of them, I think, did take, a couple of them took the first round of composite. But that was a little too much in addition to their daily, schedule. But it's available to them. It's after hours. We're not going to take a 12-year-old or 14-year-old, but we do screen people. It is important. Are they going to show up? Are they going to complete the assignment? These classes are hard. They have homework. And they expect you to do it. Really, But it's amazing when you talk to them, the excitement that they have. They actually get to also do the things. We have the equipment, and I think that's the part that I want you to run that hands-on class because I want to see how it's done. Without having to do the homework.
But does it sound like it's attracting that many people to go into the composites manufacturing business? It sounds like incumbents and
How is that
too.
How new is it?
See, I'm still doing, so I know with me one.
So how many?
Four.
Yeah, but how many rounds have we done?
I think just two rounds. Two full
So it's
rounds.
not really enough data yet.
Right.
But I think that's the challenge, is to get the attention of the student body and engage them in these things. That's where the career week really, I spoke at one of those seminars at Career Week, and, you can tell these kids really have not been engaged in what they're going to be doing in 3 years of their lives. It was a new experience for a lot of them, and to have 3 or 4 people in the industry come in and say, okay, you're taking our classes, what are you going to do with that? Where are you going to be in 3 years? You go to college, you go to work, what are you going to do? We got very little conversation back and forth, and finally we started getting some wheels turned, and you hit them with that every year. Hopefully by senior year, they start.
Well, or even something like this, having a paper, every young guy in this industry, as just a citizen of Hamilton, it's very, good to understand this kind of.
And one thing that we actually discuss, it's not just for the employees, but also for middle management. It's also an opportunity to have some of your middle managers take some of these classes and get a better understanding as to what are all these steps that, are being taken. Because sometimes you live in a bubble, and unless you live in a little bubble and you get to talk to other people from other companies, that cross-pollination, that networking is really extremely valuable. And one of the benefits that we all think this program would bring to the companies is also not just the people on the floor, the people doing the work, but those that are selling, understanding how things are done, understanding just reading a blueprint. It helps you have the way to sell the product better, the way to talk about what you do better, the way to promote your company better. And that came out of one of I think probably the second wave of people that came, we realized, oh my gosh, that's a benefit we never thought about. Because we had a couple of people joining just for the fun of it, and they really realized aspects of the composites that they hadn't thought about. So that's also something to keep in mind, not just the workers going up the rank, but also middle management. That makes, if people understand what you're talking about when you're talking about, some of the numbers that you had, that makes a difference. It becomes real, and that's the reality that in a non-threatening environment, which is, you kind of hang out after work and have to do the homework, but you get to talk to someone who does it, who understands it, who designs the curriculum. So you get to talk to someone who's not trying to make you work harder, but someone who's trying to make you work better. And I think that's another thing that we all need to keep in mind as far as everything that we offer. There's always another way to deal with your return on investment. You invest in the people in your company also by helping them understand what they do better. Is that what you said?
I think another aspect of it that does matter is the difference between a job and a career, and being able to grow your own and move up in the company makes any career more interesting.
But how many positions, like manufacturing positions, do you think are open that aren't getting filled because you can't train them through the community college program?
I would say high double digits.
How many?
High double digits.
But is that because people the kids coming out of school or whoever just don't want to do it? Do they just think that there's something better out there to do?
I think it was Jim's slide that showed the percentage of engineering graduates, which is low on a global basis. So,
It's engineering. We're talking manufacturing. This is manufacturing businesses that you guys are teaching in the community college.
Right. And to be fair, some of these openings are on the second and third shift, which historically are the hardest to fill. But they do usually have a premium pay for those off shifts, so, But I think, Kathleen, you attended a series with the Vermont State College system, and the professor said, what's your biggest need? And your response was engineers. Yeah. So it's really across the board, and you guys might be able to explain this a little bit better than I, but there's that relationship between the engineer and the folks on the floor. So as you hire more engineers, the concept is there's going to be more production people to support that engineering work. So it tends to go in a relatively parallel path. Any other questions? Well, I know that there was a lot going on this evening, and I just want to thank everybody for showing up. Thank you for CAT TV. So the folks who were not able to hear what was going on tonight, hopefully they can catch that in the loop, and it's still a beautiful evening. So thanks, and enjoy the rest of the day. And if you didn't sign it.